In section 8.2, we're doing operations with matrices. So the first operation is matrix addition. So if you would like to add two matrices with the same dimensions, you add their corresponding entries. The sum of two matrices with different dimensions is undefined. So the matrices have to be the same size because you're going to add their corresponding entries. So entry 1, 1 would be added with entry 1, 1, and so on. So if I want to do A plus B, I just go entry by entry. So the first top left, 1 plus 2 is 3. I'm going to go down the column, I think, -2 plus 1, -1, -7 plus -4 is -11. Then I'll go ahead and go down the second column, -3 plus 6, 3, 4 plus 0, 4, 0 plus 3, 3. Okay, and so because I added two matrices of the same size, my result is also the same size matrix. Okay, the second one is going to have scalar multiplication along with subtraction. So scalar multiplication, to multiply a matrix by a scalar, I multiply each of the entries by the scalar. So to start off, if I do 3a, I'm just going to multiply every single entry of a by the scalar 3. So now 3, -9, oops, not -2, -6, 12, -21, and 0. And then from there, I'll subtract matrix B. And I'm going to go component by component, and the resultant will be the same size 3 by 2 matrix. Okay, so then this is my final result. This was my final result here. Okay, next one is matrix multiplication. Matrix multiplication is different than scalar multiplication. In scalar multiplication, we are multiplying by one single value. In this case, we're going to multiply two matrices by each other. They don't have to be the same size, but they do have to kind of match up. So it says if an m by n matrix and B, if A is an m by n and B is an n by p, the product AB equals C of matrices A and B is such that Cij equals AI1, B1, J, blah, blah, blah. I'm going to show you. We're basically going to do row by column and then find the sum. Okay, so I'm going to do row by column and then find the sum, and I'll show you what I'm talking about when I say that. Okay, so row by column. So first row with first column on the second matrix, I'm going to multiply the corresponding entries and then find the sum. So the first one is 2, 2. So 2 times 2 is 4 plus 3 times 2 is 6. Okay, now I'm going to go to the, should I do it? I'm going to go down. The second row with the first column. If I do the second row with the first column, then it goes in row 2, column 1. And I'll multiply the corresponding entries again. The first one goes with the first one. 1 times 2 is 2. 1 times 2 is 2. Okay, then I'm going to go ahead and go to row 3, column 1, and that'll tell me the entry that goes in row 3, column 1. Okay, so 5 times 2 is 10, minus 2 times 2 minus 4. So I did all of the first column. I'm going to go to the next column now. Okay, so if I want to do row 1, column 2, row 1, column 2 is going to go over here. And I'm going to multiply the corresponding entries. So 2 times 5 is 10, 3 times 2 is 6. And I am going to ask you to show this step on your work. Okay, which one am I going to go to next? Row 2, column 2. And I'll do the corresponding entries. So 1 times 5 is 5. 1 times 2 is 2. And then what do I have? Row 3, column 2. 5 times 5 is 25, minus 2 times 2 is 4. Okay, that's the step I'm going to ask you to show. And then the resultant vector is going to be 10, 4, 6, 16, 7, 21. So that is the final answer after I do the multiplication. Okay, and I'm going to point out something about the dimensions because they don't have to be the same size, but you do need certain elements to match up for this to work out. Okay, so if I look at the first matrix, this was a 3 rows, 2 columns, 3 by 2. The second one was a 2 by 2. Okay, if I want to multiply it, since I'm doing the rows with the columns, these two have to match because otherwise it's not going to work out. On the next one, I'm going to make it not work out. Your resultant is going to end up being this size. So in this case, my answer ended up being 3 by 2, 3 rows, 2 columns. Okay, now I'm going to go ahead and look at B. Okay, so now for B, I'm going to show you that it's not going to work out, and then I'm going to show you multiplication-wise why it's not going to work out, because most of the time you don't check this before you multiply it, you just do it. So this is a 2 by 2. This is a 3 by 2 because it's 3 rows, 2 columns. Okay, I can already tell that these don't match. So this is not going to multiply. I'm going to try to multiply it so I can show you that if you try to do it, which is what I would do, it's automatically going to fail. Okay, so if I do the first row times the first column, 2 times 2 is 4, 5 times 1 is 5, and then there's nothing left to match up with that third element because you're doing 2 elements with 3 elements, so it won't work. So in the case where the dimensions do not match up properly, this matrix multiplication is undefined. And I could tell by either looking at the dimensions at the beginning or just trying it out and seeing that these don't match up. This is 2 elements, this is 3 elements. Automatically a fail. Okay, the third example of matrix multiplication, it says D equals this matrix. Find D squared. Okay, if I want D squared, I'm just doing D times D. So I'm going to write out D times D 2 times and then do matrix multiplication on it. These are 2 by 2 by 2 by 2. So this should work out. And again, I'm going to go row by column and then find the sum. So row 1, column 1 equals 1 plus 6. Okay, and how you organize yourself is kind of up to you. I think I'm going to go row 2, column 1. Row 2, negative 3 plus 12. And I do ask you to show this one little step. Okay, now what do I need to do? Row 1, column 2. Negative 2 plus 8. Row 2, column 2. Okay, I just need that one step. Yes, I know it's magical, but there's lots of magical calculators that can confirm your answer. Okay, and then this is my result of D squared. And it makes, because it was 2 by 2 by 2 by 2, it makes sense that D squared is in fact also 2 by 2. Okay, the last example is an application. I'm going to use matrix multiplication for this application. The multiplication part is very easy, but getting the units to line up properly takes some thought sometimes. Okay, so it says a fruit grower raises 2 crops, which are shipped to 3 outlets. The table shows how many units of each crop are shipped to each outlet. Here's the table. Okay, the profit per unit for crop 1 is $3, and the profit per unit of crop 2 is $7. Use matrix multiplication to find the profits for each of the outlets. Okay, I'm going to look at the question first because I want to think about what I want my result to look like so that I know how to set up my multiplication. So it wants me to find the profits for each outlet. So I'm thinking, what am I trying to find? I'm trying to find profits by outlets. That's what I want my result to be. Okay, now if I think about matrix multiplication, that means I want my first matrix to be profit by something. And I want my second my second matrix to be something by outlets, because remember, this will make my result be profits by outlets, and I need these two to cancel out, or they need to match up. Okay, so what's the third element I have? This says outlets and crops, so the third thing must be crops. So I want profit by crops times crop by outlets, and now I just need to make my matrices match up with this. Okay, remember the first, this is the rows, this is the columns. So I want rows of profits. Let me write this. Row is profit. I want the columns to be crops. How many crops are there? 2 crops. So crop 1, crop 2. Okay, let's see. What is the profit per crop 1? The profit per crop 1, is it given? There it is. Crop 1 is $3. Crop 2, $7. Okay, now what am I multiplying this by? I want this to be crops by outlets. So I need to make sure that my rows are the crops and that my columns are the outlets. Okay, now I'm going to look at the table. Actually, right now the table does have crops for rows and outlets for columns, so I'm going to keep the table exactly as it looks. If it was not matched up the way I wanted it to match up, I might rotate it. I would change the table so it does match. Okay, now that I have it lined up properly, I'm going to use matrix multiplication, and my result should be the profits by the outlets. Okay, and yes, you're going to show me that one little step. Okay, so row 1, column 1. $300 plus 7 times 120, $840. Okay, now I have row 1, column 2. 3 times 70, 210 plus 7 times 50, 350. Row 1, column 3. 3 times 70 is 210. 7 times 80 is 560. Okay, now in this case, if I had multiplied this incorrect, if I had set this up incorrectly, my matrix multiplication would have come out to be undefined, and that's one way to check, but there's no guarantee that that will happen, especially if I have square matrices. Okay, now this is my resultant vector. Not vector, sorry, wrong chapter. This is my resultant matrix. If I did it correctly, and I did, this is the profit by outlet. Okay, and if it asks me to write it as a sentence, I would say outlet 1 makes a profit of $11.40, outlet 2, profit of $5.60, outlet 3, $7.70.